Find the fourth roots of I in exact polar form. So now we're going to look at other complex numbers. Well, let's think about I. So I is here, and that angle is pi by 2. So we're going to say let z to the 4 be equal to I. And then z to the 4 would be equal to cis pi by 2 plus 2n pi. We should really specify here n is an integer. I might actually forget to do that at times, but you should do that. And that's just simply because it doesn't matter how many times we go around, once we land back there, we're on I. And that's what the 2n pi is all about. So z would be equal to cis. Now think about this. We're taking a fourth root. We divide everything over here by 4, and that would make that pi by 8, not pi by 4. And plus 2n pi divided by 4, which is n pi divided by 2. So we want to make sure that we end up between negative pi and pi, and it should only be included at the other end. Okay, so I might try n is equal to, well, pi by 8's here, isn't it? So I can take two right angles off and still be in the right region. So we'll go n is negative 2, negative 1, 0 and 1. And so we're going to get cis, so we've got pi by 8, take away pi, so that would be negative 7 pi by 8. And then we'd have, with the negative 1, pi by 8 take away pi by 2, so pi by 8 take away 4 pi by 8, so that would be cis negative 3 pi by 8. And then with the 0, it's just going to be cis pi by 8. And finally, with n equals 1, we've got pi by 8 plus pi by 2. And that would be 5 pi by 8. So cis 5 pi by 8. Once again, if you draw these, it will be beautifully symmetrical. Our first one would be at pi by 8, like so. They'd all lie on the unit circle in this particular case. And then there would be pi by 2 between the solutions.